Can everybody hear me all right? All right. Okay, so here's what I'm going to talk about. I'm going to do an introduction, talk about a couple of security basics for AWS. I'll talk about AWS specific security features. And then I'll get the end, I'll close with an actual security breach that happened at a company I was at. All right, so my name's Scott Johnson. I live in Fishers. I've been building stuff my whole career, which at this point is a really long time. I'm a full stack developer architect. I work mostly in Ruby and Rails, Python and Elixir, less Elixir than I'd like. I use Ansible for all DevOps stuff, and I'm really happy with Ansible. I do AWS for a cloud provider, and I really like AWS. And I'm doing a bunch of machine learning these days. My consulting these days is focused on doing monitoring and detection of hate speech. And I've been using AWS since they first launched S3, so that's about as long as anyone, since it was the first service AWS ever launched. All right, so a couple of security basics. All right, so the first thing to understand is that AWS locks everything down by default. And this is good, so all you really have to do is don't screw it up. Right? Now, there's one thing where they don't actually lock things down, and that's around the root account, and we'll cover that when I get to talk about IAM. All right, so this is Security 101, which basically means EC2 and sort of the very basics. So when I look at the cloud, what I basically see is this vast panoply of Unix boxes out there. So this boils down, so then if you accept that as a premise, then your corollary is that securing the cloud is securing Linux. And what that means is any breach that affects Linux probably affects your cloud instances. And that includes yesterday's breach of sudo, which was just announced. That's sudo -1 stuff, which is really tricky and has been there apparently forever. All right, so I'm not talking about serverless. I'm not talking about Kubernetes. I'm not talking about Fargate, et cetera. This is just the basics. All right, so we're going to play word salad here. And these are the topics I'll be talking about. EC2, basically instances. IAM, the user architecture. Security groups, which basically amount to firewalls. API keys, PEM files, which I don't really talk about much because there's not that much to talk about. VPCs, VPNs, and CloudTrail. And finally, encryption. OK. So let's talk about EC2. So just EC2 is basically, it's an instance. It's a virtual computer or an actual computer in the cloud, depending on how you perceive these. My personal mental model for the way AWS data centers are run is that they've harnessed the elder gods, and they're sort of running them all off the brains of an elder god. And all the tentacles are just the network cables. So that's my visual that I work with. So when you think about EC2, there's a couple of things to think about for security. One is the security groups, and these are the firewalls that govern access to and from the machine. Your IAM role is key, and this is the place where AWS does not lock things down by default. Okay, and this is the place where you can get yourself into a lot of trouble. And there's a little checkbox, which I'll show on the next screen, which is Enable CloudWatch Detailed Monitoring, and this is actually really subtle and really important. Okay, so when you walk through the web UI for creating instances, and yes, everything should be automated, and we should be doing DevOps, et cetera, and someone is still in your organization going to use the web UI because it's there and it's easy, even though it's crappy. So there are these two little options that you check off, and one is what your IAM role is, and this says what permissions does this machine have, and the other is Enable CloudWatch Detailed Monitoring, and I'm highlighting these because I'm going to talk about them later, but they're an easy place where you make a security mistake right from the get-go. And I say that having made those mistakes. All right, the next thing to understand about your EC2 instances is your default is shared tenancy, okay? Which means that technically someone else may be running on the same hardware as you are at the same time, which opens yourself up for possible exploits against yourself, and it depends on to the degree to which you trust the underlying hypervisor, right? Like if you believe in virtualization and you really trust it, you don't worry about this. If you're old school and you find this scary, old school, then this is a concern. So if you're doing something that's really sensitive on the machine, you may choose to actually opt for dedicated hardware. It's a lot more expensive, but it is at least an option. And things like reading crap out of memory, yes, that actually can be done. All right. So IAM. So this stands for Identity and Access Management. It's basically the AWS user architecture, right? And AWS preaches this by default and says you really should use this, but it's not one of those things that they can enforce on you because how your roles work in your architecture is defined by you. So when you normally when you get an AWS account, you basically have a root user. And that root user has God permissions. It can do anything. So if you don't go and take advantage of IAM, your AWS account can do everything, and this can be leveraged against you. Hence the case study. So IAM basically amounts to role-based users, and the permissions can be limited with IAM users. They can't be limited with the root user. Okay? That's an inherent limitation or benefit to AWS, depending on your perspective. So the bottom rule of thumb is you really should never, ever use the root user. And to make matters, now, the thing that you can do that will really get you into trouble is when you create your access keys can be created by the root user, and then if you start using those, everything can be compromised very easily. Okay? And I didn't really allow for that being not so readable. I'm sorry. All right, so when you start walking down the IAM user path, it basically gives you the option to start by list your roles, and those are here. Or actually, I don't really have a mouse, so you can start by creating roles. By default, AWS gives you 7 odd roles, which aren't terribly sophisticated. Okay, and so then you go through the create role, and you can tell it things like, these are the services I want this role to actually be able to do. So if, for example, you don't want the role to be able to get into SageMaker and have access to GPUs, you can lock that out and just have it be just, say, basic EC2 permissions. Okay? Roles can have policies, and policies can limit what can happen. And the nice thing about this is underlying all the permissions, if you see that JSON button, is permissions are just JSON documents. So if you're doing DevOps, the way to think of this is basically your DevOps is going to create text files that are JSON and that are uploaded to AWS. Okay? And that's going to define what permissions your role has. Okay? Like everything else in AWS, you can have tags attached to your roles, so you can understand what they are and manage them. Okay, and these can be them as granular as you want, right down to the user level, or it can be truly role-based, like this is my web server role, this is my database role, and so on. Okay. And it forces you to do the review process at the end. And this is the getting your user roles right is one of those things. It's going to take trial and error, and it's an iterative process. It's not a simple thing to figure out what permissions you want because it's so damn granular. There's over 200 plus individual discrete permissions that you can actually employ here. Okay. Security groups. So security groups are really simple. They're simply firewalls. They're a set of permissions that say things like allow traffic on 80 or allow traffic on 443. Okay? And allow SSH in or out, etc. Okay, so they're just traffic filters. You want to think of this in terms of the last place I worked, we had one security group, and it was this large. And that's really, really bad. And it wasn't mine. I inherited it. But I still had to manage it every day and deal with it. So you want to have multiple security groups, and you want to think of these things in terms of composability, right? They're small, and they add up and do what you want. All right. So you have when you start doing this, you might be doing this from a DevOps perspective and be writing this purely using Ansible or SaltStack or CloudFormation or what have you. Or you might simply build this interactively. So your default security group is SSH, and it's going to give you the ability to SSH in. So every one of your boxes you create will have a security group attached to it, and the default is to get in. I was redundant there, I'm sorry. AWS has done a very good job of identifying all the common protocols. So if you know this is a box that's going to talk to the web, you put HTTP and HTTPS on it, and then whatever else you need. Okay? Do yourself a favor and make the names actually not suck, because the names you get from AWS, how can I say this less than politely? They suck balls. They're horrible. Okay? The default name is Launch Wizard 1. It doesn't actually even say it's for security. It's Launch Wizard 1. What? Okay. So make the names good. Understand is that the names actually are there, they're descriptive and they're for you, because what's actually attached onto your AWS boxes or your AWS things is the underlying object ID. So you can change the names ad nauseum. There's no excuse for the names being bad. All right. Said that. Yeah. All right. API keys. An API key is a set of credentials that give access to a service. So think of this as a username and password for machine-to-machine communication. Okay? So basically big binary hexes, or big actually ASCII hexes that are generated. And you typically, these get stored on an AWS instance in tilde/aws/credentials. They often are set as environment variables. Rotate these regularly. Okay, so when you're doing your DevOps work, build in the facilities to rotate these regularly and make it easy for yourself, because if you don't make it easy for yourself, I can guarantee you that you will not rotate them regularly. Okay? And when I do consulting work, I just include this as a line item, like I'm going to write the rotation tasks and sell it to you. And it's a good way for a consultant to make a little bit of extra money. All right, PEM files. These aren't particularly sophisticated. These are simply private key files used for SSH in. The one thing to watch out for is they tend to be created at EC2 instance creation. You can reuse them, but if you create them and then you lose them, well, you can't recreate them, and that usually means losing access to an entire box. Okay? So that's a problem. All right. Your VPC. Your VPC is short for Virtual Private Cloud, and it's essentially a virtual network that's there only for your AWS account, and it segregates traffic from everything else. Now, when you start doing this, you think, well, we're a company, we have a VPC, and that's all we need. In actuality, you are not limited to one VPC. You just tend to think that you are. So you can have a VPC per product, per team, or per company, or you might want to segment out your dev environments from your test environments, or whatever. Amazon's actually fairly liberal with this because they recognize there's a lot of benefits to them in having this. Okay? And it tends to make things more auditable as you go. So definitely consider more than one of those. All right, VPN. I have, as a software developer, I've had VPNs enforced on me through most of my career. And I never really got it until really recently. So VPN, Virtual Private Network, everyone here knows this. So the IT guy takes the perspective of a VPN makes us secure. Hallelujah, we have a VPN. And I look at it as a developer, and I say, well, SSL makes us secure. And then you think about the SSL code base, and you sort of wonder, maybe not. But anyway, both of these are actually true. And this really became very apparent to me when I left the company I used to be at a couple of months ago, and they still retained me as a consultant, and they wanted to turn me on and off, basically in times of crisis. So, and this is where the VPN comes on. The VPN gives IT a really easy way to turn somebody on and off, because it's a traffic choke point. Essentially, if you have to have the VPN to get into your AWS account, just turn that user off on the VPN level, and you don't have to disable all of their access, right? Now, there are some caveats here, and you have to be careful because it's security, and there's a lot of gotchas. But this is why IT really likes this, is because the day I left, they flipped that switch, and they didn't have to worry about every account that I had on every other machine. Okay. All right, CloudTrail. And I referenced this earlier. Enable detailed AWS CloudTrail monitoring. And I'm going to give you the official AWS speech here because, man, it's a nicely written paragraph. So the idea of CloudTrail is it's a centralized log for everything that happens with your account, right? And so theoretically, if there's any bad actions, you should be able to go back into CloudTrail and find this out, right? Because it logs everything. They say it logs everything. Well, remember that checkbox. If you were stupid and didn't turn it on, actions on that instance will not actually be in CloudTrail. Or if your AWS keys have root access, bad actors will turn off CloudTrail to hide their actions. So my answer there is no. In my opinion, CloudTrail should not ever be turned off, but it actually because it uses a lot of space, AWS makes money off it. All right. So CloudTrail, in case you haven't dove into it, it's basically it's an event store. So it basically just tracks events and gives you a temporal index into them. Okay. And events can be drilled into, and there's a canonical set of things that there are here, like the error code, the region, the source IP address, et cetera. So this is all really useful when you're trying to figure out who in your organization blew it, right? Because at the very least, you can get back to an IP address, and that's useful, okay? And ideally, you hopefully aren't using a single user account to get into all of your AWS stuff, but we all know that happens. You can search across CloudTrail, which is supposed to be useful. It's not been as useful as I would like. And then you can even go so far as to finding custom CloudTrails. Okay, and this is something I don't actually understand all that well, but theoretically you could say, I want all the actions related to this product or this region to flow into this particular log. And like everything else in AWS, all of this ultimately ends up in an S3 bucket. Okay. All right, encryption. One of the things that AWS has done a lot recently is they basically pumped up what they do with respect to encryption. So now you can do things like you can encrypt your S3 buckets. You can encrypt your EBS volumes at rest. You can even encrypt your RDS stuff at rest. And so the basic idea here is if it's not being used, no one else should be able to attach to it without your encryption keys. And they have a whole facility called, I think, KMS, which is Key Management Service, which lets you manage your keys, et cetera. And it's one of those things that at this point, there probably is no reason not to be encrypting stuff, okay? All right, so now I'm going to talk about a security breach case study. Okay, so I used to be, you can call me a security denier. I used to think this stuff didn't really happen, or if it happened, it was because you screwed something up. And that is actually not necessarily the case. So it was August 2018. It was, I think, the 18th day of the month, or it might have been the 19th. And I clearly remember this. And the first thing to note is it always happens on a Saturday, right? And the reason why bad happen on Saturdays is because that gives bad actors the most time to exploit you, right? Like their window starts the end of business, California time, US, and then they look at it, they have the whole weekend to play with. And we saw our AWS bill at the time was 11 grand a month. And we had a $25,000, our bill went to $25,000 that day. And yes, AWS did not view that as bursty enough activity to shut things down. They just let that bill run the hell up, which really surprised us. And what happened was Bitcoin mining. So we had root keys, and our API keys were used to launch a whole bunch of big GPU instances, and someone actually made a whole bunch of money in the ledger that day. Never found out who, because it would be a pain in the ass to do that. So the first thing when you've got a security breach is what do you do, right? Panic, run in circles, scream and shout was where we started. However, the first thing we did was we deleted our access keys, okay? And we had an advantage that most people in this room don't have in that we didn't care if our systems were up and running because it was a Saturday and we sold to education. No one ever used our service from the end of the day Friday till Monday morning. So we had like 2 days to clean this up. And it took about 6 hours. So the first thing we did was we deleted our access keys. And that stopped a bunch of things. However, there were still a bunch of instances that were running that even if the GP, there were still bills going to be incurred. So we then went and killed those boxes manually, and then we idled on the EC2 monitor, the EC2 instance list, making sure that no new instances were kept coming in, because there's a lag time there. Then the next thing we did is we built new access keys, okay? And then we fed those into our deployer, and this is, in the times of crisis, that's when you realize how good or bad your deployment architecture is. And then we redeployed. All right, but we weren't done yet, right? Because we had a problem in the first place that we didn't have role-based security. So the next step was we rebuilt our access keys with limits, okay? And we did it quickly, which means we didn't do the best possible job. So there's a step 3.5 in here, which isn't shown, where we rebuilt it again. And we probably did it more than a few times. And then we deployed again. And then we did step 4, and which is the worst step, is we did the postmortem, okay? And I'm going to talk specifically about that. All right. So now, and this doesn't apply to every consulting firm out there, but we had originally gotten our code base from a consulting firm. It was a company out of well, I'm not going to say anything, because they've cleaned up their practices since then. But any employee who had ever worked at that firm had access to all of our boxes, okay? Because they had one repository of security keys, and it was just shared across the whole damn bloody company. They did not do any key rotation when people left the security firm, the consulting firm. So, and we went back and figured it out. By the particular key that leaked, it came out of the ones that they had, not the ones that we had. So one of the rules of thumb is if you get code out of a consulting firm, do a security audit, right? There are lots of good consulting firms out there, but everybody can make mistakes. So you always do a security audit when you get code from somebody from outside the organization, because their concerns aren't your concerns. And if you have to spend dollars with somebody else, the last thing you want to do after having written a big check to a consulting firm is spend dollars with somebody else. You still do it, right? Because you never ask the fox to guard the hen house, okay? And that's what happens when you have this person who wrote it do the security audit. All right, so what did we learn out of this? Well, the first thing we learned is that GitHub repos are constantly monitored for security keys by bad actors. And GitHub tells you this, and they try and make you aware of this, but until it happens to you, you don't really believe it. The second thing is gitignore is your friend. Okay? If you're not using a gitignore file to prevent secure stuff from going into your repo, you're making a mistake. And the next thing is if you don't have a pre-commit hook doing the appropriate things to your source code before it goes in, you're also making a mistake, because once things go into a repo, it's hard to get out, because you can always go back through the history. And the final thing is if you're using a deployment system, whether it's Ansible or Chef or SaltStack or CloudFormation, always encrypt your keys, okay? So what else did we learn? Now this is the business stuff. Well, the first thing we learned is that AWS is actually slow to refund your money. And that bill, which went from $11,000 to $25,000, we paid the $25,000 because AWS does not give you that money back. They do not annul those charges right away, okay? And I don't know if it was that we had a crappy relationship with AWS or it was everybody, but they sure as hell kept that money for a while. The second thing is they take this stuff seriously, and they're not going to refund your money twice, okay? Because they view very clearly in their security guidelines that a big part of the security responsibility is on you. And the final thing is you can spend a lot of time trolling through CloudTrail, and it is not actually as useful as it should be. And maybe that's user error on our part, or maybe CloudTrail isn't as good as AWS says it is. I can't entirely decide. All right. So the next thing is you do the damn postmortem, okay? And the best time to do a postmortem is when you don't want to do it. It's after you solve the technical issues, when you're beaten down and discouraged, and you've managed to put your ego away for the day. So you do it then. And there's 2 questions for any postmortem. How the hell did this happen? And how do we keep it from happening again? Right? And that's all you're really there to learn. Okay? And quite honestly, you want to understand blame. Right? Not because you want to fire somebody, but because that's the only way you prevent it from happening again. And then once you get these things, you teach them internally. Right? You don't deny your mistakes. You own it, you fess up to them, and you tell them to other people on the team, because the next person will not be you, but it will be someone else. All right. And I think we're about out of time. I have a couple of I have a couple of extra things. If we have more time, where are we at? Okay. All right. So I tossed in a placeholder slide just in case. I ran quick. So common AWS security errors. 6, because that's all I could fit on the slide. It all starts from access. If you're stupid and you have a bad password, this is going to hurt you. Okay? And a lot of times when you have an Amazon account and it's a company thing and it's not your personal thing, people aren't as careful as they are when it's their own credit card on the line. Not using 2-factor auth, right? We all know we should do it and we all hate it because it's a pain in the ass. Having access keys on your root account, that was what bit us. Okay? That's the single biggest mistake that you can make, because an access key on your root account is basically God access. And there's a lot of cool stuff that you can do with AWS that people want to exploit these days. A whole lot of cool stuff. You want to rotate your keys regularly. Okay? And this was a lesson that company did not learn, because the keys that we put in August 2018 are still there. Okay? And I don't think they rotated them after I left. Right? Now, I'm still signed to a consulting agreement and non-disclosure, so it's probably okay on that part, but even so. And as a general comment about cloud-based development, right, our set of keys for things, third-party services we access was like this long. When somebody leaves, how the hell do you rotate all those well? Right? That's a hard problem. Exposing data in S3 buckets. If you've never looked at the security permissions on S3 buckets, the complexity there is terrifying because of everything S3 does. Like, it's actually really hard to know when a bucket is even public, apparently. So be careful there. And then the final thing is not check in your bill every single day. When you have cloud services, so like in the company I was at, we were about 100 people. We spent $11,000 a month on AWS then. It's currently up to about 20 grand a month. And that's the single biggest check the company writes every single month. And not one person is actually responsible for looking at it. Right? Now, in what other industry would you have a $20,000 bill going out and no one responsible for it? Right? You know, and the problem is it cuts across all organizational boundaries. Right? So who owns it? I don't know. And that is everything. So thank you.
Let's give Scott a big round of applause. We have time. We could take a couple questions if anybody has some questions for Scott around this. I have one. So what system do you use to rotate your keys?
I wrote custom Ansible scripts to do it. I like Ansible for DevOps. It's the simplest thing I've found that actually works well. And I having spent 3 years doing Chef and Puppet and hating it, and I'm a Ruby guy, and I still hate Chef and Puppet. Underlying Chef and Puppet is Ruby. That's why I picked it the first time, and it's horrible.